here we see some examples how we can obtain the regular expression from the given transition graph. So we have already seen the informal description of the algorithm in other video. So algorithm step 1 says that we have to go for the simplify. You can simplify first, means you should have the one initial state that has no incoming edge, and you should have only one unique final state, and from that final state we should not have any outgoing edge. This is the first simplification we need to do. Then we can go step 2, and step 2 says that we have to bypass and eliminate the states of the given transition graph one by one. Okay, the process of elimination of the states, the process for bypass and elimination of steps is very simple. So a state is bypassed by connecting each incoming edge with each outgoing edge. Okay. So we have also seen the examples how you can eliminate and bypass the state. So the main important thing in this algorithm is we have to bypass and eliminate the states one by one, and the order is not important. We can eliminate the state in any order. So order is not important. Okay. So how long you can eliminate the states? You have to eliminate the states one by one till you have only the two states left. One is unique initial state and other one is the unique final state. We have done at the step 1 simplification, during the simplification, and the label on that edge from initial state to the final state is actually your answer. That is the answer, means that is the resulting regular expression that defines the same language as defined by the given machine. So if you have more than one edge between the two states of the transition graph, the direct edges going on the same direction, then we have to unify them by adding their labels. So this is the algorithm. Using this algorithm, step by step, we will be able to obtain the equivalent regular expression. Once I say equivalent regular expression, this means we are going to obtain the regular expression that defines the same language as accepted by the machine. So here we will see some solved examples. If we are given the transition graph like this, so this is the initial state, and this is final state. Double circle denote the final state. Okay. So according to the algorithm step 1, if you go for step 1, then we have already one initial state, and in this initial state there is no edge coming from any state. So there is no edge coming from any state. There is no incoming edge. And also you have the final state, and from the final state no edge is going outside. No edge is going to exit. So the step 1 is satisfied. Now what we need to do? We need to bypass and eliminate the state in this transition graph one by one, and we can fix some order. This we have fixed the order. So if we are going to eliminate the states one by one, let us see, we first eliminate the state 1, then we will go for the state 2, then we will eliminate the state 3. So see, once you go for the elimination, So how you can eliminate the state 1 from this transition graph? So we are eliminating state 1. So when you eliminate the state 1, then what is the result? What is the equivalent form of the graph you are going to obtain? So 1 will be eliminated, means you have to bypass the state 1. So what is the incoming edge of the 1? This is 1 incoming edges, and the outgoing edge is 2. So one goes to the state 2 and other goes to the state 3. So we have to bypass this state. This means we have to eliminate this state, and we will have the direct path from the initial state to the state 2, because this is one outgoing edge, and we will have the direct path from this initial state to the state 3. And this is the initial state. You are going to the state 1 for the null transition. We are going to eliminate the state in order 1, 2 and 3. So first we are going to eliminate the state 1. So what we have now, if you are going to eliminate the state 1, then we have the initial state here. This is the initial state, and now state 1 will not be here. We have the state 2 and we have the state 3 here, and then we have the final state here. This is the final state. So these transitions are as it is. So we have everything is same. Now what is here? We are eliminating the state 1. This means state 1 will not be there. Means we are going to bypass the state 1. And once you are going to bypass the state 1, this means you have to connect the incoming edge of the state 1 to the outgoing edges. So from the initial state, incoming edges for the null, then you have the A. So you have to go for the concatenation. You are concatenating with null and A, and the result is A. So you have the direct edge from the initial state to the state 2, and the resulting label is A. From the initial state, you can also, other outgoing edges goes to the state 3. So you have the null B, means you are concatenating null with B, and answer is, resultant is what? B. So you have the direct edge from initial state to the state B, and the resulting label is B. So this we have done. So after elimination of the state 1, this is the equivalent form we have obtained. Equivalent form. So one by one, actually we are going to obtain the equivalent transition graph. That means whatever the language defined here, we are obtaining the same language defined by this equivalent form. Now we need to eliminate the state 2. So whenever we are going to eliminate the state 2, then state 2 now will not be there. So the state 3 has loop. From state 3 to the final state, we have the edge with label null. Then from initial state for the state 3, we have the label B, edge, and label is B. Now we are going to bypass the state 2. So once you bypass the state 2, then from initial state you are going to the 2, then in the state 2 you have the loop, then outgoing edge goes to the final state. Means we have the direct path from the initial state to the final state. And what is the resulting label? We have A, then at state 2 we have the loop, so this is for the B clean star, and then we have to concatenate with A. So A, B star A, B star A. This is the resulting label. Okay. Now this is one outgoing edge. Other outgoing edge is from the 2, it goes to the state 3. So you have to also specify this. This means you from the initial state you can go to the state 2, then you have the loop, then you are coming to the state 3. This means from the initial state to the state 3 we also have age. So we also have the age from initial state to the state 3. What is the level of this age? The level is we have A, then B clean star, then you are coming to the state 3 for the level for A. So from the initial state A, then you are going to the state 2, you have the loop. So you can say that this is the B clean star, then you are coming to the state 3 for the level A. So A, B star A, this is the resulting level, and we have the direct age from now from initial state to the state 3. So from the state 2 we have the two outgoing age, one goes to the final state and other goes to the state 3 we have considered. Now in the state 2 also we have the incoming age from the state 3. So once you are going to the state 2 from the 3, so we have the B, and you can have the clean star at the state 2 because 2 you have the state loop at the state 2 for B, and then you are going to the final state. So from state 3 you are going to the final state. So you are going to the final state. What is the level for this? We have the B, then B clean star because you have the loop at the state 2, then you are going to the final state for the A. So you are going to concate. So A, so we have the B clean star A, B clean star A from 3 to final state, B clean star A. Now is there any other possibilities? Yes. So once you start from the 3, then for the B you are going to the state 2, then you have the loop at the 2, then also you are coming back to the state 3. This means we have the loop. So you will also have the loop at the state 3. So what is the value, what is the level of this loop? So from the state 3 you are going for the B, then at the state 2 you have the loop, so B clean star, then you are coming back to the state 3 for the A. So B star A, this is the loop you have. So these are the two possibilities. From 3 you can go directly to the final state and the level is B star A. The other is you from 3 you can go to the B, so from 3 you can go to the state 2 and coming back to the state 3 again. So this is the loop, and for this case the level is B star A. So B clean star A. So we have two outgoing age, one is this and other is the other goes from the state 2 to 3, one goes from 2 to final state. So that's all. So you have also eliminated the state 2, means you have bypassed, by bypassing the state 2 and elimination you have this equivalent form. One thing is more, you can further simplify this. So how you can simplify this? From here you can say that this is the initial state and we have the final state here. This is the final state and we have the state 3. So state 3 is this, we have the state 3, and from initial state to the final state we have the age. So you can say this, and this is the level of this age is A B clean star A. Now from initial state to the state 3 you are going for the, we have now two parallel edges going in the same direction from initial state to the state 3. So we have to add them. So you are having the situation like this. So you have B, one is B plus A, B, clean star A. So you have resulting edges, like you have unified, and on the unification you have added the labels of these two, and the resulting edges from initial to the state 3, and the label is B plus AB clean star A. Similarly, from the state 3 to the final state, you can do like this. From 3 to final state, we have the two edges parallelly going in the same direction from state 3 to the final state. So you can say, you can have the null plus B star A. So you have the resulting edge. Now you have the loops at the state 3. So we have the loop. And what is the level of this loop? We have the loop in the same state, and we have to add the two loops. So resulting level will be A plus B star A. So A plus B clean star A. This is the resulting. So now we actually, this is, you can simplify to this. Now we need to eliminate the state 3. So once you are going to eliminate the state 3, then we have only the two states. One is, this is the initial state, and other will be this. You can say this is the final state. Now from the initial state, we are going to eliminate the state 3, means you are going to bypass the state 3. So once you are going to bypass the state 3, then we have already one edge going to the state final, from initial to the final state, for the label AB, for the regular expression AB clean star A. This is the regular expression. Now we need to eliminate the state 3, means we are going to bypass the state 3. So we have a direct edge. We also have direct edge from initial state to the final state. What is the level of this edge? We have B plus A B clean star A. So B plus A B clean star A. B plus A B clean star A. Then we have the state 3, and at the state 3 we have the loop, and so you can say we have A plus B clean star A, and we have the loop. This is the clean star. Then you have to concatenate with the label, which is the null plus B clean star A. So once we have eliminated the state 3, means once you have the bypass the state 3, then we have the direct edge from initial state to the final state, and the level of this state is level of this edge is, we have to go for the concatenation, this, then this clean star, and then this. So B A B clean star A, and this should be concatenated with. So actually we have to make a grouping here. This is, so you have to concate B plus AB clean star A, B plus AB clean star A with A plus B clean star A, then you have the whole clean star, then you are concatenating with the label null plus B clean star A, and this is the, after elimination of the state 3, we have this equivalent form. Now you can further simplify it. So how we can simplify it? So once we go for the simplification, since we have the two edges parallelly going on the same directions, so we have the two edges from the initial state to the final state. So from the initial state to the final state, we have now two edges, and the direction of the edges are same. So you can unify them. So once you go for the unification, then we have this initial state, and then we have this final state, and I can write something here. This is the final state, and from initial state to the final state, we have only one direct edge. What is the label of this edge? So you have to unify this, means you have to add. What you need to add? A, B clean star A plus this thing. So you can say plus, this is the resulting label of this. So now this is the stopping condition of your algorithm. Why this is the stopping condition? Because we have no other states of the transition graph left other than the initial state and the final state. So this is the initial state, and this is the final state. So we have only the initial state and the final state. No other states are left. We have eliminated all states one by one. So the resulting label of this direct edge is what? This. And hence this is the answer. This is your regular expression. So this is the regular expression. This is the, you can say, this is the equivalent regular expressions. This is the regular expression for the same language, as the language of given machine. So this is the, so we have the resulting regular expression. So this is the answer. So this is the way we can obtain the regular expression. Okay. So you may have the question now here. We have eliminated the states according to the order 1, 2, and 3. Now, if you change the order, like if you can eliminate first state 3, then you can go for the state 2, then you can go for the state 1. Whether you are going to obtain the same regular expression like this? No. You are not going to obtain the same regular expression. You will have some different regular expression once you change the order. But the value of the value of the regular expression, whatever you are going to obtain, will remain same. Means the language defined by this regular expression and the language defined by the regular expression, once you eliminate the state according to the order first 3, 2, and 1, will be same. Hence, you can go to the any other order, the whatever regular expressions you are going to obtain, they will define the same language as the language accepted by your machine. So order is not important. You will get different regular expression, but that regular expression will also define the same language. Okay. So you see that we are going to eliminate the states in this order now. And we see that on going to this kind of elimination in this order, what kind of regular expression we are going to obtain. So see, we are going to eliminate the state 3 first. So eliminate the state 3. We are going to eliminate the state 3. So what we have? State 3 we need to eliminate. So from 1 you are going to the state 2 for the A, then you have the loop at the state 2, then from the state 2 you are going to define state for the A. We are going to eliminate the state 3. So state 3 will not be here now. We are going to bypass this. So once you bypass, then you have to join the incoming edges and outgoing edges. So we have the direct edge from 1 to final state. 1 to final state. What is the resulting level? So from 1 you are going to the state 3, and this is for the B. Then at the state 3 we have the loop. So B A clean star, B A clean star, and then B A clean star, and then you are going to the state final state for the null. So once you concatenate null, then the result is B A clean star. So you have the B A clean star. Okay. Other thing is you have the outgoing edge. One goes to the final state and one goes to the state 2 also. So from the state 1 you should also have the edge from 1 to 2. So we have the edge from 1 to 2 also. What is the level of this edge? You are going from 1, you are going to the state 3 for the regular expression B. Then at the state 3 we have the loop. So this is for the A clean star. Then for the regular expression B, for the case of B, you are going to the state 2. So you have the edge from 1 to 2, and the level of this edge is B A clean star B. Now there is also one edge coming from 2, state 2. So you have, and if you are coming to the state from the state 2. So for what you are coming from the state 2? For the case of A. For the A you are coming to the state 3, then from the 3 you have the loop for the A, and it goes to the final state. Means you should have the edge, direct edge from 2 to final state. So you should have the edge from 2 to final state. And what is the label for this? You have the A. For the A you are coming to the state 3, then at the 3 you have the loop for the A. So A clean star. Okay. So from 2 you are coming to the state 3 for the A, and the 3 you have the loop for the A clean star, and then you are going to the final state for the null. And once you concatenate here null, then the result is A clean star. So this is one thing. Other possibility is that you are coming to from the state 2 to the state 3 for the A, then you have the loop, and again you are coming back to the state 2. Means you will have the loop. You have the loop now. So what is the level of this loop? You are at the state 2, you are going to the state 3 for the A. Then at the state 3 you have the A loop for the A, so A clean star. Then from 3 you are coming back to the state 2 for the B. So A star B. This is the level of this loop. So once you have 2, from the 3 you have the 2 outgoing edge, one goes to the final state, one goes to the state 2. So from 2 you have the direct path to the final state, and from 2 also you have the loop. So this is the simplified form. So from here you can obtain to this form once you have eliminated the state 3. Okay. So you can further simplify this. So what you can simplify this? You have seen that these are the parallel edges going on the same direction. You have the 2 loops, and here is also 2 edges going in the same direction. So you have to go for the simplification. So you can obtain, so you have obtained the equivalent form after the unification. Now we need to go for the eliminating the state 2. So we are going to eliminate the states in the order 3, 2 and 1. So we are going to eliminate the state 2 now. So eliminate state 2. So how you are going to eliminate the state 2? So we have, this is the initial state, and from the initial state you are going to the state 1 for the label null, and we are going to eliminate the state 2 means you have to bypass the state 2. So once you bypass the state 2, then state 2 will not be here. You have the final state, and this is the final state you have, and you have the direct edge from 1 to final state. What is the label? So label is A plus BA clean star B. You have to concatenate this with B plus A clean star B, and then since this is the loop, you have to make the clean star again. Then you have to concatenate with this. So you have A plus A clean star, A plus A clean star, and other edges you have the edge which has the label BA clean star. So whenever you have eliminated the state 2, when you have the bypass the state 2 and eliminate, then you are having this resulting form. And again here you have the 2 parallel edges, so you can unify them. So once you unify them, then you have the BA clean star plus all such things. Now we need to eliminate the state 1. So now we are going to eliminate state 1. So whenever we are going to eliminate the state 1, then now state 1 will not be here. So you will have only this is the initial state. You have the initial state, and you will have this is the final state, and you will have only direct edge from initial state to the final state. What is the label? The label is you have obtained, and this is the resulting regular expression. So this is the resulting regular expression that defines the same language accepted by your machine, accepted by the given machine. Now you can compare this regular expression with the earlier one, and you can come to know that this regular expression does not look the same as the we have obtained once we have eliminated in the order 1, 2 and 3. But one thing is sure, that this regular expression also defines the same language as defined by the regular expression you have obtained by eliminating the states in order 1, 2 and 3. So if you don't know how you have obtained this, and then there will not be any clue to prove that whether these two regular expressions define the same language. And we have to follow the steps of the algorithms, then we are confirmed that these two regular expressions are actually defining the same language as accepted by the given machine. So you can go for the obtaining the regular expression, and while you are going to obtain the regular expression, you are going to bypassing and eliminating the states one by one till you have only the two states remains. One is initial state and other one is the unique final state, and you have only the direct edge from initial state to the final state, and whatever be the level of that edge, that is your answer. So you have obtained the answer. So using this algorithm, this kind of method, you can obtain the equivalent regular expression for any given machine. Let us see some other example also. So we have the FAs as shown in this, and you know that in this FA we have the two final state. Your FA start from the state 1 and you have the two final states. What we are interested, we need to obtain the equivalent regular expression. So we are supposed to go for obtaining the regular expression such that the regular expression defines the same language as defined by the machine. Say this is the machine M. The language defined by the machine is what? This is the LM is the language accepted by this machine. So we are going to obtain the regular expression such that the value of the regular expression is the same as the language accepted by the machine. This is our objective. So we need to obtain the regular expression for this given f. So how we can do? You can use the algorithm. So first is we have to go for the simplification. So here we have the two final state. We need to make one final state only, unique final state. And we have the, here you have the initial state also, and the initial state has incoming edge, and we don't want such initial state that should have the incoming edge. So you have to simplify. So we need to go for the simplify, step 1. Simplify. So after simplification, this is the result. Now you can eliminate the states. Okay, so we can eliminate the states one by one. So you can fix some order. Say you are going to eliminate the state 3. Okay, we are going to eliminate in the order say 3, 2 and 1. You can eliminate in as per your convenience. There is no harm. You can eliminate in any order. So we have the transitions like this. Now we are going to eliminate the state 3, means you have to bypass the state 3. So how you can bypass? You see that once you bypass the state 3, then if you are coming from the state 2, if you are coming from the state 2 to 3, then it is for the B you are coming to the state 3. Then from 3 you have the outgoing edge which goes to the state 1. So actually you will have the direct path from 2 to 1. So you have the direct path from 2 to 1. And what is the level for this path? this edge B, then you are going for the 1 for the level A. So you are concatenating, then you have the BA. So you have the BA. So you have the B and then A. This is one. You are not coming from the state 1. So, okay. So you are just coming from the state 2 only. So from the state 2, you are coming to the state 3, then you are going to the state 1. So you have the direct edge from 2 to 1. And the label is BA. Now other possibilities is that you are coming from the state 2 to 3 for the B, then again for you are going to the state 2 for the B. This means you have no loop now. So you are starting from the state 2 for the B. Once you go to the state 3, you are taking the B, and for the B you are coming back to the state 2. So you have BB. So for the BB, for the regular expression for the level BB, you have the loop at the state 2. So these are the two outgoing edge from the state 3. One is it goes to the state 1 and other goes to the state 2. Okay, and you are just only coming from the state 2. And so you have the bypass the state 3, and you have one direct edge from 1 to final state for the null. So this is the form you have obtained. Okay, from this you can simplify these two, and once you unify these two, then you have the A plus BA. The resulting edge will be A plus BA. Okay, this is the simple form of the machine. So what you have, everything is same. Initial state is same, state 1 is same, also state 2 and final state. State 1 you have the loop, from the 1 you are going to the state 2 for the B. From at the state 2 you have the loop for the BB. From the state 2 to 1 you are coming for the two parallel edges, and hence we have added this. So you have unified the A plus BA, and from 1 to final state you have the edge for the you have the direct edge and the label is null, and from the state 2 to the final state you have the edge and the label is null. So this is the simple form. This is the form you have obtained. So this is the equivalent form you have obtained. Now we need to eliminate the other state. So you are going to eliminate the state 2. So how we can eliminate the state 2? So when you go for the elimination of state 2, then we have, this is the initial state. This is the initial state, and we have the state 1. This is the state 1. From the initial state you are going to the state 1 for the null. Okay, and we have the loop here. We are going to bypass the state 2. Okay, so once you bypass the state 2, then you have only the final state here. You have only the final state, and the one is from 1 to final state is what? The one is for the case of null. Now you have you are at state 1, you have the loop, and you have the final state. You are bypassing the state 2. So once you are going to bypass the state 2, this means from state 1 you are going to the state 2 for the B. Then you have the loop, and you are going to the final state. Means you should have the direct path from 1 to final state. So you have the direct path from 1 to final state. What is the label of this resulting edge? So label is from 1 you are going to the B, sorry, 1 for 1, from 1 you are going to the state 2 for the B. Then at the state 2 you have the loop for the BB. So BB clean star. So you have the BB clean star. Then you have to concatenate with null. So once you concatenate BB clean star and null, then the result is same, B BB whole clean star. So you have the age from 1 to final state. 1 from 1 to final state. B BB clean star and then final state. So this is one outgoing edge here. From the state 2 you have one outgoing edge which goes to the final state, and other edge goes to the other outgoing edge goes to the 1. So if you are starting from the 1, okay, and for the B you are going to the state 2, then you have the loop at 2 for the BB clean star, then again you are coming back to. So actually you are having the loop here. What is the level of this loop? So from 1 you are going to the state 2 for the B. Okay. Then at the state 2 you have the loop for the BB. So BB, and you are going to have the clean star. Then you are coming back to the state 1 for the regular expression A plus BA. So you have A plus BA. This is the resulting level. So from 1 you are going to the state 2 for the B, then from 1 you are going to the state 2 for the B, then you have to repeat BB any number of times, 0 or more times. So BB clean star, then you have to concatenate with the regular expression A plus BA. So 1 to again you are coming to the BA, and this is the resulting level for the loop. Okay, so in this way you have bypassed the state 2, you have eliminated the state 2. So you have only just two outgoing edge. One goes to the final state and one comes back to again to the initial state, means the state 1. Now this is the resulting. So what you can do, you can simplify this. You can simplify this again, and once you simplify this, then what you have, and this is the equivalent form you have obtained. Now eliminate state 1. So we are going to eliminate the state 1. Once you go for the elimination, so you will have only now two states. One is initial state and other will be this is the final state, and you will have the direct path from initial state to the final state. What is the level? What is the level of this? The level is you have null, you are concatenating this null with this with, and then with you are concatenating with this. So you have the answer. Okay, so this is the resulting level you have obtained. So once you concatenate null, you are going to concatenate with null, then you have the loop A plus B, BB clean star, A plus BA whole clean star, because this is the loop, and you are concatenating with the regular expression null plus B, BB clean star, like this, and this is the answer. So whatever you have obtained, this is the regular expression. This is the regular expression you have obtained, and this is the regular expression you have obtained which defines the same language as the given machine. So this is the answer. So this is the answer, and your algorithm will stop now. So your algorithm stops when you have only the two states remains. One is the initial state and other one is the final state, and you have only one direct edge from initial to the final state, and the answer is what? Answer is the level of that edge. So this is the way we can obtain the regular expression from any given machine. So if you are given some machine and you want to obtain the regular expression, then you can follow the steps of the algorithm, and by following the steps of your algorithm step by step, you are building the regular expression. And once you have the two state left only, one is the initial state and other is the final state, and you have the only one direct edge from initial state to the final state, and whatever is the level of that edge, that is the regular expression, that which defines the same language accepted by the given machine. Okay.